students, a warm welcome to the module on Boyle's law. So far we found that there are four types of relationships are possible with measurable properties. Among these, first relationship is between pressure and volume. I will show a video. You please watch it and find out what is happening. Yes, you can see that the piston of a cylinder is moving inward due to the force applied to the piston. What is happening to the volume? Yes, volume is decreased by applying the pressure. What about the temperature and the amount of substance? Is it changing? No. So, how do we express this relationship between pressure and volume? At constant temperature, the pressure of a fixed amount of gas varies inversely with its volume. The scientist who made this first reliable measurement of the properties of gases is an Anglo-Irish scientist named Robert Boyle, and the relationship was formulated in 1662. The relationship between pressure and volume at constant temperature is called Boyle's law. So we can state Boyle's law as at constant temperature the pressure of a fixed amount of gas varies inversely with its volume. Now we can represent Boyle's law mathematically. The measurable properties of gases such as pressure, volume, temperature and amount of gas are represented as P, V, T and N respectively. In Boyle's law, we found that the relationship between pressure and volume is inversely proportional at a constant temperature and the amount of gas is fixed. Then you all please try to represent the Boyle's law mathematically. For the pressure we can use P and for the volume we can use V. Then the representation of Boyle's law become P inversely proportional to 1 by V. We can remove the proportionality by a constant. So the equation becomes P is equal to K into 1 by V, where K is constant, or we can write PV is equal to a constant. That means product of pressure and volume is a constant at constant temperature and number of moles. Now I will show a video which is showing the expansion of gases from one state to another state. For the state 1, the pressure of the gas equal to P1, and for the state 2, pressure of the gas becomes P2. At state 1, the volume is equal to V1, and for the state 2, volume is equal to V2. Then you please try to represent these states according to Boyle's law. That is, for the state 1, pressure is P1 and volume is V1. And for the state 2, pressure is P2 and volume is V2. So we can write Boyle's law for the state 1 as P1 V1 equal to constant, and for the state 2 P2 V2 equal to constant. So for the change in state from 1 to 2, the equation becomes P1 V1 equal to P2 V2. Now you can see a table showing the effect of pressure on the volume of 0.09 moles of carbon dioxide gas at 300 Kelvin. First you observe column number 1 and column number 2, that is pressure and volume. What happens to the volume when the pressure varies? Yes, as the pressure varies, the volume value decreases. So they are inversely proportional. Now let us draw the graph showing the variation of pressure with volume. What you can infer from the graph? As the pressure increases, volume will decreases for the gas. Now let us consider columns 1 and 3 of the previous table. Column 1 is pressure and column 3 is 1 by V, that means reciprocal of the volume. How the values for 1 by V is varying with the pressure? Yes, they are directly proportional. So you please try to draw the graph connecting pressure versus 1 by V. Yes, the graph will like this. Now let us consider column 1 and 4 of the previous table. Column number 1 is pressure and column number 4 is pressure into volume. What happens to the value on column number 4, that is pressure into volume, with respect to column number 1? We can find that PV is found to be a constant. So how can we represent it graphically? So we draw three graphs. One is pressure versus volume, then pressure versus 1 by V, then pressure versus PV graph. In all these graphs, one of the measurable properties are found to be constant. Which one is that? Yes, all the graph is plotted at a constant temperature. So such plots, that means graph plotted at constant temperatures, are called isotherms. What is the meaning of isotherms? Iso means same and therm related to temperature. So they are called constant temperature plots. So isotherms are constant temperature plots. Now we shall move on to the derivation of an equation which connecting density and pressure. You have to write the equation for density of a gas. Which is that equation? Yes, density is equal to mass by volume. Here D is density, M is the mass and V is the volume. We know that PV is equal to a constant according to Boyles law, or we can say that V is equal to K by P. We can substitute the value of V in the equation for density. So we will get density D is equal to M into P divided by K, or D is equal to K dash into P. From this relation you can see two variables, one is density and another one is pressure, and K dash is a constant. So what is the relationship between density and pressure? Yes, density is directly proportional to pressure at a constant temperature. So we can conclude that density is directly proportional to pressure. Now let us solve one problem. A balloon is filled with hydrogen at room temperature. It will burst if pressure exceeds 0.2 bar. If at 1 bar pressure the gas occupies 2.27 liters volume, up to what volume can the balloon be expanded? You have to solve this problem. Here you can see that two pressures are given. One is P1, that is 1 bar pressure, and another pressure P2, that is 0.2 bar pressure. At 1 bar pressure the volume is 2.27 liter. So two pressures are given and two volumes are to be used. So we can use the equation P1 V1 equal to P2 V2. P1 is 1 bar, V1 is 2.27 liter, P2 is 0.2 bar, so we have to find out V2. You have to substitute the values in the equation P1 V1 equal to P2 V2. Then you will get the answer V2. V2 is equal to 11.35 liter. So up to this volume you can expand the balloon. Hope you all understood the Boyles law. Thank you dear students. Thank you. We will meet in the next class.